Okay, I'm just gonna start because there's a lot of cover today. Okay, so we'll finish the material for the exam first, so let's get started. Okay, so we left off here. So we're gonna talk about transactions today along with other functions. Now, transactions, after this introduction of transactions, we'll know some syntax of transactions, but fundamentally, we'll come back to this slide and to discuss and review again what the characteristic of transactions enables relational database. Okay, so let's take a look at transaction. I spoke about it before. So in a nutshell, what transaction is kind of like try-catch blocks. It's not really, but it's similar to a try-catch block in Python or Java, whatever coding language you have. And the syntax is like this. Look it over here. So you would start a transaction by saying begin transaction. Okay, remember, you have to specifically say when you're typing in select statement, whatever SQL statement, you can still run it. But if you want to have the transaction characteristic, meaning that you want to be able to roll back or you want it to be hard forced commitment, then you need to say begin transaction to enable the transaction features within SQL. Okay, so the first thing you'll do is transaction, and then with regarding to the final stage, we'll look at it later. But in between, just look at how simple everything is. Just statements, statement followed by statement. So just different procedures that you want, or different functions that you want to call or whatever, right? So between your begin transaction and your final, whether you want to commit or roll back, you just have different lines of statements and SQL queries. Okay, so basically, what happened here is you can do begin transaction, and then everything here, such as update or insert, anything within this transaction, until you finally said what you want to do, finishing up this transaction. All these can be rolled back. All of them. Meaning that if you were, it's almost like temporarily affecting your tables, temporary. In addition to locking others from accessing, not deleting others. If others are also trying to connect to the same table, it's just on hold. You're not deleting their request. If they're sending like a select statement while you started the transactions first, separately, autonomously guarantees you that you can still have the priority because you started first with your transaction. So other people, when they're trying to query and stuff, they need to hold. They won't be, their query are not deleted per se, but they're on hold until you finish your transactions. Okay? But anyway, simple put is when you have the transaction, you begin until you say you want to commit everything in between your transaction block. You can put as many queries as you want. Okay? And within simple as that, if you say commit, all of these, assuming they were successful, all of these then would forced to be saved into your database. And now you're releasing the database tables so other people now can do their work. Like they can query, they can do their transaction. Okay? It's trying to prevent also race conditions. So transaction is very important when you have transaction functions in banks, in other software that you need transaction functionality. Okay? This is just another one. Again, begin transaction, that's how you start. And make sure that this is what you're trying to have this transaction. You want to have autonomously again, and you want to make sure that everything you do is relevant to one or nothing, right? If one fails, you want to have ability to roll back, which we'll discuss next page on how we roll it back. But if they all were successful, then you can commit. Okay? Now, you might ask, how do I know if it's all successful, right? So it is not as intuitive as you would say in Java or like when you're coding in JavaScript or whatever. type of language you choose, you do, if you want to kind of fully automate it, you do need to have some type of test. You do need to maybe set like a Boolean or whatever, right? You do need to check if they're actually successful. Okay, but regardless, the transactions allows you to say that, okay, if I start a transaction and then until I say commit, everything here could be rollback, or I change my mind. I just want everything to backstack. Never happened before. Okay, that's what transaction does. All right, remember the syntax here. Yeah.
So if we had the same solo,
Yeah.
we just had GTM translation, we can use that command. Would each line just kind of get permanently modify the database after we run that line?
Yeah. Yeah. So it's kind of almost like I mean, when you're just doing, and then don't get me wrong, there's a lot of code out there that's just simply use statements, SQL statements alone. And when you query as well, like select statements and all that stuff. So don't get me wrong, those are still going to eventually be stored, right? But this gives you an opportunity where, like, especially you're not only have one statement. Like you have consequences, basically like you want update, and then you want to know that it's correct, then to the next function, meaning that there's a couple of steps, especially when that is the case, and those steps is important. Those case is opportunity and candidates for transactions. But if you're just doing like one, for example, then that's not maybe like one statement when you're doing like update just one row and you don't want to do anything else, maybe not as much. Okay? All right. So you can imagine that if you are calling, like say, if I go to ATM and the actual step when I insert my card, putting my PIN and all that stuff, all the way to get my money and receipt out, you want that to have automaticity so that there's nobody else who's using my, let's say, my secondary card holder using the ATM that can have a dirty read, then that is what transaction is doing. It's locking this session so nobody can kind of interfere during the session. But at the same time, if let's say when you're doing ATM and then at the last page, you type in a number that's more than your balance, and then the system may decided that this will be canceled. And then if it canceled, it just roll back to nothing happened before. So this is basically, think of it, that's what the transactions really shine, okay? So, but just remember, okay, how do you start it? And then commit is when you're forcing your changes into the database, like you're saving it, all right? After this commit, you cannot say a rollback. After this commit, if you want to roll back, it will roll back to this when this is all done. Like basically it will already be set in stone. And you cannot put a rollback right after. You have to start another transaction to do rollback. So let's take a look at how rollback works. Okay, similarly to commit is forcing it to stay. Rollback, you still need to have a begin transaction, okay? These are paired, okay? So let's say begin transaction have all the things, but it turns out there's some error. It turns out when you say update, blah, blah, there's no customer ID, but whatever. So simulation of an error, that's it. And you type rollback, basically it will go back to like there's nothing ever happened before. Systematically, it'll just do that. Okay, or maybe what happened is you do an update and then you realize that, oh, this customer ID is not actually 123, it's actually 125, and you made a mistake. So you roll back. So the database will feel like there's nothing happened. Yes.
What's the previous slide?
Previous slide. Commit.
Yeah, because then when you always want to go back to the same. How do you know if you're hearing that there's an error when you go back to the same?
So you just missed what I just said. You can't actually. So okay. I want to clarify. It may be slightly difficult because this, you have to think of it like, how many of you already have MySQL or Workbench downloaded and then tried it, right? So you have to think about when you're at that, open the panel that you can start typing out SQL, right? This is actually you typing line by line. This is not, this is, don't imagine it as like, this is it's not, we're not talking about stored file function here. This, you can type it, you can actually type begin transaction and then in your database and you run it and you type this and run it and you type line by line and run it. If you were doing that line by line while you have your workbench open, you will see the error. You might see the error, right? Because you might. But let's say if you're automating it, which we'll learn about later on when we talk about store procedure, like you want to write a file of all these blocks and using transaction, then you need to define some sort of function to check. Like you will need to use some check. You need to write some code to check it. For example, you'll check like, okay, for example, if you have an insert, right? And after that, you will check like, okay, is now the table adding one, it's the row count is more than just added one. For example, that type of check you have to do, right? And then with that, then you can say like, okay, if the check works out, you can commit. If not, then you can roll back. Okay? All right. So this is how you commit again for those just come in, okay? And then this is how you will roll back. Okay, roll back the entire, let's say there's just only one statement, which is not a great example, but let's say there's multiple, rollback will go back all the way to the beginning of the transaction, okay? But however, just like I mentioned before, when you are typing directly in the editor of your SQL editor, right? Imagine now you're starting your Workbench client and it's still not automated. Maybe you want to save like a checkpoint. You want to save a backup point so that, okay, you begin transaction, okay, and then you want to say, update something, blah, blah, first. Then you type another save point, transaction, save it here. Then basically whatever, if that was successful, it will save up to there. So if you type rollback, it will roll back to wherever your save point is. Okay, it just gives you an extra bonus in transaction. Let's say if you want to like save partially instead of the entire block of code. Okay, so very simple transaction. Just remember the way you start a transaction and you can start practicing at home if you want to. You will say begin transaction in order to have a start. And then just don't do just transaction. You have to remember it's begin transaction, right? And then followed by whatever you want to do. And then this basic one is just commit or rollback, right? And if you want to have adding a little bit of extra and then you have ability to save halfway or along the way, then you'll set save points. Okay? Very easy to understand. There's not that much different. But that's come back, as I mentioned. What does that give you as your transaction data? Why is it so important to learn about specific transaction, right? So number one is exactly the example I just made, right? There might be some times that you are updating a database or you're interacting dynamically with the database and it's a group of commands, not just one, right? For example, like I just mentioned, if it's the ATM, first of all, you are insert your card, right? And then the card needs to find who you are. Then you enter your password, and then you have to check if it's matched. Then you'll say that look at balance, whatever, and then withdraw balance, and then look at balance again. All those things, right? You will want to have it all or nothing, right? Because you want to all or nothing because you don't want someone who has your secondary authorizer use the same card, accessing your account, and then take out money while you started your transaction first, like an ATM, right? So it basically holds this in, when you begin a transaction, it holds all the affected table temporarily, locking them so that there's no raise condition. Okay, so that's the second feature of this transaction. That's the second benefit of transactions. Not only that allows you to easily roll back or commit, but it also locking anyone else who is accessing and trying to change the table that you're interacting with this transaction. It's again, let me repeat. Don't confuse when I say locking another entity with deleting another entity to trying to query it. There's a difference. One is just waiting. The other one is trying to delete it. It's not deleting anything, okay? As I said, if there's someone else during your transaction trying to update, they will be on hold. They will see spinning sign until you're done. But they don't get on error or they don't get deleted just because they came next after you. Okay, there's a difference with that. You have to be very careful when you're selecting, when you're understanding this concept. Okay, all right. So really is the transaction also is really what made relational database also known as transactional database, right? And also why the ACID is equivalent to relational database, right? Because really other database or storage file storage doesn't really have transaction built in to the like relational database relational databases do. Okay, all right. So that was transaction. Now, before we go and talk about store procedure, right? We have to think about why there is a need or why the feature of a store procedure exists and how is it relevant, right? What again will be a use case that will be helpful to have store procedure. Now that has to do with designing your relational databases with your software, right? So it's your front end or whatever, or your applications that is talking to your database. Okay. Now, when you're designing software, and maybe you haven't seen this before, but this is good to know. There is as you became more seasoned, and let's say you have been at your job like maybe for a year, or when you start interning, you're going to start hearing these words: functional requirement and non-functional requirement. If you were to starting to build or design a software from scratch, okay, your stakeholder or your boss or the company's manager or whatever, CEO, may have an idea. And that idea, he wants to build into the app, or you are the one who is the CEO and you want to build a new app, and you have certain requirements. Those requirements for a software developer, right? For a full stack developer, let's say, you're normally categorized into two different parts. One is functional and the other one is non-functional. So this is going to be quite important for you to also know, because this will also help you with your final project. Now, functional requirement, what is that? Functional requirement usually are able to say, like, for example, if I want to have Instagram, my functional requirement may be to be able to create an account and being able to upload a picture, be able to upload a video. Those are all use cases, right? Actual functions to the app. That's why it's called functional requirement. So those are the functional requirements. The non-functional requirements are more like when you're talking about building this app, some of the things that you would want about your application. For example, you want this application to be fast, right? It's more of it's rather than I'll say how to, it's more like how well about this app, right? So think about you want to be fast, or you want it to have a mobile app, mobile native app, as well as a desktop app, right? So those are not directly impacting the use case, but it's enabling your app to become better. Or you want to have maybe one account can have multiple delegates. Like, well, actually, that will be a functional requirement. So, okay, so maybe you want the database to be back up every day, or you want to be back up in different regions, multiple backup files, right? It doesn't really impact the end user directly. Those are non-functional. Now, for those of you who just starting to design or have software database design, I don't know, how many of you guys take software design already? Have you guys learned about this functional requirement? Okay, so then what is also another, I don't know if your professor teach you. So what is the secret in another word? Remember how I give you guys this shortcut to remember what one to many and where is the many table, where would the core flow be for the one? Remember I give you a tip? Remember, anybody can tell me the tip that I gave you? Those are very good tips, I mean, in my opinion. What is, no one remember? How do you recognize very quickly in seconds when there's a one-to-many relationship, especially it's 2NF, right? You're breaking many to many to a transit table, and then you're like thinking where's one, where is many? How do you quickly do that? Yeah.
Child table has the primary key of a different table, or like it has a foreign key. Table.
Say it louder.
It has the foreign key of a different table.
Okay, so my recital that I give you, the shortcut to remember, to really quickly differentiate that is the parent table has primary key, which is the DNA of the parent table. Remember that? Remember this now? The child table inherits the DNA from the parents. So that's where the foreign key is, because that's inherited from the primary key, which is in the parent table, right? Now, one single parent can have multiple child, but multiple child can have one father or like only one father or one mother, right? One to many. So it's very easy when you're breaking many to many relationship, have a transit table. The transit table is always the one that consists with your foreign keys, right? So that's always the child table and always would have the many sign. Why? Because that's the one parent can have many child, right? It's inheriting the DNA from the parents. Similarly, can you tell me, is the one who took software design? Okay, is there a tip that your professor told you how to differentiate functional or non-functional? In some like a quicker shortcut, rather than thinking about use case, yeah.
Functional is what the system does, not functional is how the
Say that again?
functional is more about what the system does, not
Okay.
functional is about how it does it.
Yeah, that's true. So you're probably right. So it's what it does and how it does. So what is the, you're right. So I'll correct myself first of all. What it does is more functional. The non-functional requirement is how, right? That's correct. But I'm thinking about another tip that's even, if you're at an interview, it will help you even faster. And it works for database and work for software design, like when you're creating. I'm asking those who took this class before. Maybe you just don't remember. Something had to do with testing. No? Don't ring a bell? Who took software design before? No? No one ring a bell? Normally, the secret sauce is normally the features and cases that you can unit test are functional requirements. The ones that are not unit testable are normally the non-functional requirements. If you need integrational test, like database connection, for example, or you need to back up, those you cannot unit test. Can you unit test like database table? Yes. You can see after you insert, you can check if it's still if it's there already, right? You can unit test that. So a good way also is if it's unit testable, it's normally categorized as functional requirement. And the other ones are non-functional requirement. Okay? All right. So just out as we are here, remember I have mentioned that you need to bring two functional requirements, the most important functional requirement for your final demo. Okay, two of the most important. Like functional requirement does include sign up. That's fine. But if you want to have one of your functional requirement being included as a sign up, then the other one better show something that is comprehensive enough to tell me about your app, right? But you just have to show two of them. Okay. Anyways, all right. So then the next thing is, let's say a slightly more traditional web development. I would say it still works today, and there's still a lot of website that does this, but it's before Web 2.0. Have you guys heard of PHP and Miami? PHP and MySQL. It used to be a very, I don't want to sound like I'm bashing it, but just trying to explain. PHP is a front-end development before Web 2.0, meaning like it's really powerful because, JavaScript wasn't standardized before. There's not that many libraries as, the HTML 2.0 before. So PHP has a really quick way for someone who is a web developer to write something similar to XML and know a little bit about HTML and being able to import PHP and to directly put your code that's normally would serve like Python or whatever on the HTML file itself, like on the XML, right? So it allows front-end user to not having to learn about like Python or Java or like JavaScript or whatever and use PHP, which is a really quick front-end development guide, but it has ability to almost serve as Python or Java and talk to the database. And what happened with that is that it gives you a really quick turnover for a front-end developer using PHP and the backend MySQL storing database to really quickly spawn on the app, a web app, very quickly. Because this PHP code has just very easy way to pick up, and then it has direct access for you to grab like tables and data that you need and make your website dynamic. Now, the problem is the fact that they have the database easy accessible created some problem. Okay, what are those problems? For example, this is how a PHP code looked like. Okay, so as you can see, in some of the code, it can directly say a query. Like you want to give a variable called query, and you put whatever select statements in here, right? This looks like whatever select statement, right? And then you can say equal to this could be left on the PHP file as an input from your input box or form, for example, right? This is an input, for example. So you can have a query that has, first of all, a set constant, which is almost like a select statement, correct? But at the where here, at the filter, this username, you can leave it as an input. Okay? So for example, you have web form, okay? And then that web form maybe is a login web form. And the user input includes username and password, right? And so PHP can grab, after you click on submit, can grab the username from the input box text field, right? And then insert it into this query. And then using this simple one-liner PHP, this is how easily PHP can connect to database. Much shorter than Python, Java, any connection string, right? It's just MySQL run query with a connection here. The connection is similar to, is there an example of connection? Okay, this connection is their connection string. It will be including like where the server is, the host, the database name, password, username and stuff, right? That would be the connection. But basically it would just say MySQL underscore query and then run this query with this connection, right? That's how easy it used to be, right? Very quickly spun off a dynamic website like this. However, it generated a problem. What that problem, later on people identified it and then gave it a name. It's called SQL injection. Okay, have anybody heard of SQL injection but wonder what it is? You have heard of it? Yes. So SQL injection is basically a result of having query exposed directly on your front-end HTML code. Like I mentioned before to you, this is PHP code, right? But when you're actually running this PHP code, it turns into HTML, right? And when it's HTML, you can press F12, for example, on your Google to directly see all the code, HTML code, right? Do we know that? Right? And what would happen is this and this will exactly expose. Now, you said that you may say that, okay, so why don't I just store this connection string in like maybe I'll put it in some type of constant file or like something that I save as a property or conduit or whatever. I store these like numbers. The store procedure actually doesn't really care about the actual connection string to access your database. It's using something that's more tricky. Basically what it does is, see over here, this equal sign and username, right? So basically what it does is that, you see, this is a select query. And remember how select query we can end with a semicolon? After a semicolon, we can start writing another select query. Right? Does anybody kind of get what I'm trying to get at? So basically, if you can see that this HTML code essentially are calling database with this function with select statement over here. Regardless if you know the connection string or not, you can inject basically here, whatever username you can say equal to like username, whatever, and then or 1 equal to 1. If I say or 1 equal to 1, then this where plus is always going to be successful, right? On top of that, after 1 equal to 1, I put semicolon, and I do select star, a select password from users, where 2 equal to 2. Semicolon, select credit card numbers from users. You see what I'm saying now? Because this is exposed essentially, a select statement. And then you're taking the input, right? So this username, I just have to extend as long as a SQL can read. And I can do validating things. And that's what SQL injection is. Okay? So, anybody so far so good? Kind of clear what SQL injection? There's not as much SQL injections these days now, but just still be wary that that's it. If you want to spun out something, PHP and MySQL combination is still very powerful stack. Like it's very fast. But this is something that you have to make sure that you don't do, or very easily you can get some type of attack because it's very vulnerable way to get to your database when you're storing like sensitive information. Now, so because of that, what next? Store procedure became sort of a way to fight or to avoid SQL injections. Why? Because store procedure now just store the function, which is the procedure's name. Just store the name of the function without revealing actual procedure and command and statement within. Okay, so that's kind of what store procedure, one of the benefit of store procedure. Okay, so basically think of it this way. You can have select statement exposed on your HTML, whatever, right? You can have all that and exposed. And that may cause some vulnerabilities, such as store SQL injection. And store procedure, one of the benefits, and where it became very popular to use store procedure, one of the use case is to resolve this problem by having whichever earlier on that query, as you see here, the query here, to be just a function name without actual table name, without actual property name, without actual statements in it. Okay? Okay, there's more. We're going to come back and talk about there's other benefit of store procedures. And we're going to talk about disadvantage of it. Now, let's look at store procedures. There's two very prominent store procedure. Actually, there's only one store procedure, but there's another type of store procedure. We're going to talk about it today as well. The first one is the most generic store procedure. And just let's look at just following on what we just used as a use case. How do we use store procedure? Look, you create a procedure, give it a name. Within that, you have begin and end. That's kind of like when you're coding, that's like your parentheses, right? Your close and brackets close and open and close, begin and end. Within it, again, you can put a while loop, which we learned last week. You can put if loop. You can put just statements. But now, you never would have to expose everything in here anymore. Because all you have to do in that PHP admin is call a procedure, this, and hit every logic from attacker. Okay? Similarly, another one over here with actual select statement here, right? Now you have no way for them to access anything else because calling this, adding more, is not going to do anything because it doesn't reveal any entity in here, no schemas in here, right? They don't know which schema is which. It's all hidden. Okay, so it's very simple example of store procedure. Okay, how do we write a store procedure? Remember, SQL, unfortunately, unlike Python, Java, C++, or whatever C#, it doesn't have the brackets for your convenience, right? Don't forget begin and end. Okay, the brackets, yes, there's probably used in create table or whatever. But store procedure, transactions, all these, remember the syntax is very specific. Okay. Now, store procedure also allow, for example, the last one, how do you actually make it so that it can take in parameters? Right? Store procedure it will be useless or it wouldn't be as full beneficial if it doesn't take in any inputs, especially if it's web, right? So you can also allow your store procedure to take in inputs or giving out outputs. Okay, or if you just want an input that could be modified and then also return that again after it's modified. It's called in-out parameters. Okay, let's look at an example over here. So I want to get office by country. Okay, so this is a declare. This is still declaring or writing, creating a store procedure named get office by country. Now, if I want to have an input parameter, meaning I want to take in some inputs, user inputs, I must specify and say in, right? And here, the name of the input is called country name, and I have to give it a data type, which shouldn't be foreign to you, okay? Everything else still the same, but now you can see that the country name now, you can use it at the select statement in the where clause over here, just like it would directly evaluate if the country equal to your input. Okay? All right, so how would you call that? Again, if you have connection string in Python, instead of writing the select start from office where country equals to whatever input field, now you would just say call get office by country, and then your input field, your input parameter is the country, which is the string data type, or varchar data type for SQL. Okay, shouldn't be that hard, but remember again how to create, and then put your statement in between and end. All right, now out parameter. If you want to have an out parameter returned, you just have to specify the out parameter. Okay, so for example, look at over here, you declare out parameter. So after you call that count order by status, because the total over here is an output parameter, outside of your SQL, you'll still be outside of your stored procedure, you'll be able to look it up by using select, right? We know select statement is to read, right? If it wasn't out, if it was an input parameter, then you wouldn't be able to, after your stored procedure, read the data, right? You will need to have the set or whatever within your stored procedure, because we know that functions, when you declare variables in the functions, after the function is closed or ended, it just goes away, right? It went to trash. Okay, this is a statement that actually we talked about last week, but let's just once again do an exercise to look at the syntax again. So over here, create procedure, as we know, get products in stock based on quantity level, and then takes in two input parameter, which both are varchar. One of them is varchar, and the other one is quantity. Okay, and in this case, you would say you're just comparing if the P operator is a smaller sign or larger sign, and then if it's smaller sign, you will compare if your current quantity is smaller than your quantity in stock. If it's larger, you're just comparing whether or not in the filter is larger than your quantity in stock. We use this if statement, but this is last week, just looking at the if statement, but now we are looking at how we are able to put if as well as while, or whatever you can think of this in SQL statement or transaction, if you will, all inside a stored procedure. Okay? Now, why do you need to pay attention to the stored procedure? Obviously, it's going to be in your exam. Number two is, if you read carefully on your final project, you need to deliver at least two places that you use rather than a statement, you're using a stored procedure. Not two use case, but two of your calls from your Node.js or from your Python need to be calling stored procedure rather than SQL statements or lines of SQL statements. Okay, remember that. So in your project, you need to apply that, and then some of these syntax is going to also show up on your exam. All right. The other is, I'll say that it is also stored procedure, but it's being called separately in SQL are triggers. The reason that it's being called separately in trigger is that because trigger has been automatically by default has certain certain ability that is even more useful than a stored procedure. Okay. So trigger, when to use trigger? So for example, I have an e-commerce website, for example, like Amazon. Okay. So if someone finish their shopping cart and pay for the shopping cart, right? All the items that they had in the shopping cart, they pay for it. And now it's being queued to be shipped or whatever, maybe, whatever you decide maybe. Normally what would happen is, that's it. When you have a shopping cart on Amazon, you have all the items that you want to buy. Then you go to a state where it create maybe another role in to ship table, for example. Right? But at the same time, you don't want to just do that because your inventory now, for example, if you're purchasing iPod in there or AirPod in there from Amazon, now you should also make sure that your inventory of that AirPod in Amazon is now -1, right? So it's actually when you place an order, the items in the order, normally how it works, if you think about it clearly, like if you're a developer, right? If someone purchased stuff, then those stuff are getting shipped out or they're getting delivered or whatever. So they'll probably go to a separate table that mark those status, whatever. But in your original inventory table, you will need to make sure that the quantity is reduced, right? So instead of writing 2 lines of code, you can create a trigger to listen. Okay, so basically how you would do that is you can say trigger, you can create a trigger when a new row is added to shipped table, for example. For my example of the Amazon, right? If you're shipping some item, if you purchase some item as a user, right? And then it's about to go to ship, right? Now the shipping table is added new rows, right? Because some items are now being pending to be shipped. So you're setting a trigger, basically it's a listener. Now, if there is items added to the shipping table, then go reduce the quantity in the original inventory table. That's what a trigger is for. Okay? Basically, it's a way of helping you clean up some actions that should take place on the other table, right? When things are moving from one to the other table, it helps you clean up, right? So, let me think of another example. For example, let's say if you have a system monitor on your server, for example, or AWS, whatever module or server that you have, and you're logging every single thing that happened, anything changes to your server or any abnormality or whatever, logging, having a trace of all the actions. Now, those are normally being stored into a database, right? So, or you can store into a file, whatever. Let's say in the case that it's stored into a database, a SQL database, you can use the trigger, right? Because if something happened, it might be added to just a log file. But at the same time, you may also want to trigger error happen in so the amount of error should be added 1 or something like that. So you want to pipe it into a table that's just logging the actions of what happens on a server, but maybe at the same time, you also want to alert and send an alert to a supporter, right? So the trigger can do that, right? So basically, trigger is for those who may want certain actions to happen by default when they listen to certain actions, and that action happens, they call it trigger. So that's what a trigger is for. Okay? The reason that it's in store procedure, it's also a stored procedure, is just simply because you can create a trigger with many statements in there as well, or many actions items in the trigger. And it's also stored as a function on your database, on your server. So that's why trigger technically is a kind of stored procedure. Okay. So the two that I just mentioned over here, one of them is the order table, right? And the other one is audit trial. So when you have time, you can take a look at it again. All right, so over here, let's go, we just go look at one of the example over here. So say I'm creating update order count. Okay, so I want to set this trigger to listen on when there's an insertion on the order table, right? So when there's an order created, basically over here, for each customer, order count equals order count plus one, where it's not the new one. Okay, so this is basically saying that I want the update to happen. I want to create a trigger. Whenever there's a new order that comes in, what it will do is go and add one to the order count of the customer who placed an order. So this is the actual actions for the trigger. And then this over here, say after insert on orders, this is actually what it's listening at. So it's listening on insertion on the order. Okay? And when there is an insert, this is what you want it to do, this trigger. Okay? All right. Over on the right-hand side, it just says that if there is anything that has been inserted, updated, or deleted on the employee table, I want to log that into the audit trail. Right? That's another actually better example than the one that I given. But basically here you create a trigger. So anything happens to employee table. If there's any changes to the employee table, I want to log it to the audit trail table. Okay, that's what the trigger does over there. There's also instead of, but you can just kind of look at it later on. But what instead of is doing is that you want to overwrite maybe some code previously, and then you don't remember where that code is stored. So you want to have a new actions. So you said it instead of, basically you're listening to, for example, you're listening to any changes in the table, but instead of that change, you want this action happens instead. That's the instead of trigger. Okay. So with that, let's go back and take a look at, let's look at how do we store a stored procedure or create a stored procedure. Now, you obviously can go and just open your editor in your MySQL whatever client, and you just type in all the syntax that I just showed you before, right? Create procedure, blah, blah, begin, end. You can do that from scratch manually, or if you're using like MySQL, for example, you can probably go in, look at your database. Normally, both your stored procedure and your trigger is normally under this thing called routine. Okay? And then maybe for Microsoft is called under function. Okay, but it's right where your table is at. That you can be sure. You can over here, you can create a procedure. This is if you want to do it the UI way, and then we'll just give you some sort of syntax, and then you just have to fill in the steps that you want to add. Okay, or you can just have it, you can write up completely from here, and then you just execute it. When you execute it, it just stores that routine, the store procedure, and then later on you have to use call in order to actually calling it. Okay. Now, right, so. Okay, so. So this is how you write the code, or this is how you write the code, and then you execute it, whatever the code you've done, and then it will be created. Again, it will be right where your table is at in that database. And later on, you use this keyword call and then give the store procedure name. Within the store procedure function name, you can also have input parameter or output parameter, right? So, okay, I really want to get to is why. Okay. First of all, we spoke about the third reason over here, right? The SQL injection reason. So now we know of that. Two other important ones. So this one is probably also very easy to understand. If you have a store procedure, rather than calling or having your Python or ORM layer to build up a query, the benefit obviously is because, as I showed you earlier, those routines are in your database where your tables are. That means that it's already on your server. You don't need to pass through your internet to get those multiple traffic, and then you don't have to pass around your query with data back and forth, right? Because it's already living on your server where your database is at, where your table is at. So you just have to make a call to the actual function name, and all the processing is on your server. So it reduces any type of transfer time of data or web calling, right? That's number one. Number two is you can reuse it, obviously. So you don't have to store your query directly on your Notepad, or your Python or your Java code. You don't have to store the statement. You don't need to store SQL on your code, right? Now you store everything with a SQL. You can validate it, making sure it runs, and it stores just where your tables are in your SQL, right? That's another reason. And on top of that, some database give you a benefit where, similar to views that I spoke about last week, some database actually cache some of the results. Just like views that I mentioned last week, some database actually cache. If you're calling a view, a lot of times you store a view and you're calling it before, let's say 2 seconds ago, it actually store the result in your cache memories, right? And so is store procedure. It will temporarily store some of your data so that it will answer your query a lot faster. But that's not to all the database. I think most of the MySQL, Oracle, all these name ones for sure. But that's also the other benefit that's in this sky, not that many people know of. What is the problem, disadvantage of store procedure though? We also need to know. Because I'm definitely not trying to sell you store procedure, and now going forward, you should all code and not use ORM and all use relational database, all use store procedure. There's also disadvantage of it, right? Especially when you're doing a CLC, when you're doing DevOps, when you're having this auto build, whatever, right? Because these store procedure needs to be stored on your SQL server. It needs to be stored on your database. So that means it's not like your code in GitHub that could be all automatically built and run on schedule or automatic build on your server, right? Because you need to actually put it, the store procedure itself, you can't not just use your pipeline. Do you guys understand what I'm talking about? Like the automatic building process? So do you guys not know how to push your code to servers? Yeah, but to server, not to your own computer. You know automatic build process? Have you guys not learned about this yet? So how many of you so far only built code on your desktop or your PC or your computer, local host? Okay, all right, okay, fine. So eventually, that's not going to work, right? Eventually, when you're at a job, your code will first live on your desktop, but then you're checking to a different repo. And that repo eventually is going to be scheduled to be deployed into production server, which is a remote host, right? It's not relevant to SQL class, but just letting you know, those processes are built so that you just need to check in your code and mark it as production ready, basically, and then your company should have a process which is normally architected by the DevOps folks, that those code, let's say every Friday, is going to, after work, after hours, it's going to automatically be deployed into production server.
Company is okay.
Huh?
Do you mean your company is okay? You're not going to give up, right? It's not.
No, they still use GitHub. GitHub is repo. It's not, GitHub is just a repo that store your code, right? Your code needs to run on a server in order to have the apps to work, right? Your app that you're writing, even on your personal computer, you need to have it run on, let's say, Python, or you need to have it run on JVM to actually run. Or if you want to have a web app, you need to run on Node.js, right? You can't have it run inside GitHub, right? So right now you're running it on your own computer, but eventually it's going to run on a server when you're working on a company, right? And normally that process is automated by the company's DevOps team, that you just, whatever you put in your repo, as long as there's no bugs, it will be marked as ready to go to production, and then it will be served to production. Okay, it's a big loop that I explained just to explain the store procedure disadvantage. But the problem with the disadvantage, one of the problem with store procedure that is a con is that this process of the automated build to your remote server is not going to work for store procedure alone. Because store procedure, just like you saw before, you would need to open up a editor in SQL or add that button of creating store procedure. You actually have to log on to your server to actually create a store procedure. Unlike your Python, you just have to throw it on a server and have it run using whatever the Python server that you use, right? So, okay, it's too detailed, but basically that's one of the disadvantage. Second disadvantage is slightly complex to maintenance because not everybody is a computer scientist or like took SQL and have some practice on SQL on store procedure. So that's another sort of syntax that you have to learn. So, and then last but not least, it's harder to debug. So there's not a typical way of debugging or unit testing a store procedure, even though you can using, SQL Server or MySQL, but there's no such a very common way to debug it, like you're debugging Python using like, IDE, etc. Okay, so with that said, that will close up everything that we have to learn new today that will be included in the exam, okay? So we are going to take a 5 minutes break. And when we come back, we're going to review the questions on the homework. And also, we're going to talk really quickly about the exam.